Go here. Alrighty, my friends. Welcome back to another lovely video. For each statement below, identify as true or false. If statement is true, explain how you know it's always true. If it's false, provide a diagram or description of a counterexample. So if a parallelogram has two sets of congruent sides, then it is a rectangle, and that is not true. And we can prove it. If you have something like this, and you have two sets of congruent sides, which you do, that's not a rectangle, right? So we can make it not be a rectangle. Those angles don't have to be 90 degrees. In fact, I could even make up some angles. I could say, oh, that's 60 and 120. Right? I could say this is 60 degrees, and this is 120 degrees. And that would not be a rectangle. The two sets of congruent sides, that's actually just a basic property of a parallelogram. It's not, a rectangle does have that, but it has more. It has to have 90-degree angles. All right, and then the second one is if a parallelogram has equal diagonals, then it is a rhombus. And what do you guys think about that one? So if you have equal diagonals, we could make it a rectangle like that. And a rhombus has 90-degree angle intersections on their diagonals. They're equal, yes, but also 90 degrees. This is equal, but not 90 degrees. So it could have been something like this, and therefore it is not a rhombus. This is not a rhombus. A rhombus has to have a 90-degree intersection of its diagonals. So that's why this one is false. All right, next up, a flowchart proof. Well, the first thing you should do when you're doing these proofs is figure out in your own mind, how do you know that they're congruent? And this should be, this I felt was a pretty easy one. This is just SSS because you know that this side is the same for both and you already have two other sides. So in my mind, I'm already thinking S, S, S. And I just want to come up with three congruency statements for three sides, three pairs of sides. And so I'll just start with the given. Doing the given is usually the easiest. So I'll say something like AD is congruent to CD. You can put the line over it if you want. And so actually I kind of wanted to color coordinate this, but that's this one here and this one. And we'll make these a different color. All right. And so then also we have AB and BC. So AB congruent to BC. And then we have this third side here. I actually didn't say, I should have said what we have. We know this because this is given. We know this one because it's given. And then this third one here, DB congruent to DB. And how do we know that? Well, yeah, exactly, reflexive, the reflexive property. Reflexive property. Okay, and once you have that, then you have to make the triangle congruency statement. Thank you for, they gave you a little hint there. So that's nice of them. And you have to follow the order. If you didn't completely follow the order, I probably took off some points. Or at least I should have. If I didn't, and I apologize. ABD, okay, so that's CBD. And how did we know? That was the original thing that I said, SSS. Right, and that's how we know that that's true. Next problem. This was fun. Again, the first thing I would say is don't be overwhelmed. Don't be intimidated. Just because you don't get it the first time you look at it doesn't mean you can't do it. But let's see what we got here. So we have given that BD bisects ADC. Hey, that's actually right here. I'll just write that in if you don't mind. And then AD congruent to DC, that's also given. But I need to, before I move on, I need to really look at these triangles and really look at what they're talking about. So BD bisects ADC, ADC is this angle over here. And so that tells me that these two angles are congruent. So this one and this one are congruent. And that's because of the angle bisector. Apparently that's not relevant until the fourth statement. So maybe I got a little ahead of myself. But I see they have reflexive property, and that's an obvious one that they want me to say this side right here. So let's write that in. DB congruent to DB. And then I already said the other one, the angle bisector. So that would be ADB. And if you just said angle D or something like that, that's not okay. Angle ADB. Hopefully I have room to fit it in. Congruent to angle, and again, I apologize for my messy handwriting. I am writing with my finger. ADB, CDB, CDB. All right, and so that means that triangle DAB, DAB, is congruent to which one? And again, you have to get this right. DAB starts on the blue angle and has the side with the 1 tick mark, so that would be DCB. Triangle DCB. Now, how did we know that? Well, what do we have? We have, let me just highlight this here real quick. We have a side, right? Then we have an angle. Then we have another side. And the angle is between the two sides. So that tells me SAS. And therefore, angle 1 is congruent to angle 2, and that would be congruent parts of congruent triangles are congruent. Congruent parts of congruent triangles are congruent. Any questions on any of these? Moving on. So we have to do a flowchart or a 2-column proof to prove the following statement. Given ABCD is a parallelogram, prove that AE is congruent to CE. So a couple of you just wrote AE congruent to CE given. I'm like, no, it's not given. Okay, but what I did tell you guys last week is that when you're trying to prove stuff in parallelograms, it's a good idea to figure out triangles within the parallelograms and just basically do what we just did on the last problem and just try to prove those congruent. And you do have some flexibility and freedom here to do it more than one way. Unfortunately, this one was tough for you guys because I think there's just a lack of structure in the problem that makes it difficult. It's not step 1, step 2, step 3, and fill in the steps. I think if it was like that, a lot of you would probably do better. So let's talk about what we know. Well, we know that this is a parallelogram, which means that this is parallel with this. And I'm just going to focus on the top and bottom triangles. I think we got to start somewhere, and I think those are perfectly suitable. So since that's a parallelogram and we have a transversal, which is AC, okay, so if you think of like there's this line that goes through these two parallel lines. And again, first I have to make it for myself before I really just write it all out. So then I say, oh, well, hey, if those are parallel, then I have alternate interior angles that are congruent. And you could certainly also do that with these. That's not the route I'm going to go, but there's no reason why you can't do that. And then I have some vertical angles. So I have this one and this one. And then, and it's not a bad idea to look at the options down below. And if you look at that, you'll see that this one right here is very helpful. Parallelogram has opposite sides that are congruent. And so since we're already given that this is a parallelogram, that's certainly a property that we have. So that means that like AB here is congruent to DC. Whoops. Oh, I fixed that little smudge. And so since these two are the same, you know, that's an S. So I'm looking at this, I'm like, oh, this is AAS. So here's how I'm going to do this. Maybe typing would be better. Let's see if we can type this up, because usually a little bit neater. We'll say statement and reason. Come on. And statement number one. Let's do this. Statement number one is that ABCD is a parallelogram. And that's given. And then we have statement two. Again, it's somewhat arbitrary where you start, so there's a couple different ways you could go. I misspelled parallelogram. Oh, I put the double L on the other one. I put the E in the wrong space. You could say that too. Number two. So yeah, there's a couple different ways to go. I started with the alternate interior angles, so that's what I'll say. So I'm going to say angle. Is there an angle symbol I could do? I don't know.
The less that are equal to?
Yeah, that's what I have. I just put this, but alright, that's fine. Just for now, everyone knows that this means angle. So angle BAE, and also there is like an ASCII congruency sign, but I'm not going to look that up right now. I'll just write equals. Everyone can just get over it. Angle BAE is, and I'm looking at the green angles. If you're looking at my screen here, I'm looking at the green angles. Those are my alternate interior angles because those are on the diagonal and the parallel lines on the inside. So on the bottom, that would be, if it's BAE, B is on the baseline, so I have to use DCE, not ECD. DCE. And so the reason why that is true is alternate interior angles. And that one is one of the reasons given. They have it a little bit lengthier. I don't know if I can fit all that. Let's see here what I can fit. Parallel lines. Alternate interior. You know what? I'll call that good. I think you get it. Okay, and then, maybe I'll just move this all over just a little bit. Give myself some more room. And then what I said is what I said was the vertical angle. But I'm going to finish with the vertical angle. I'm going to next say that AB is congruent to CD. And the reason for that was parallelogram has opposite sides that are congruent. Parallelogram. Opposite sides congruent. And 4 would then be that vertical angle. So angle AEB, let's say, congruent to angle CED. And the reason for that is those are vertical angles. Vertical angles, they have an apostrophe, okay, are congruent. Okay, and so that tells me then that the triangles are congruent. And I don't know how I'm going to do a triangle symbol, but again, just bear with me. Triangle, I'll just use the same ones from the last one. Triangle AEB is congruent to triangle CED. And the reason why I know that now is because of SAS. Yep, SAS congruent. Just want to make sure they have those listed. And now because the two triangles are congruent, then I know now that AE is the same as CE. So AE is CE, which is what I was trying to prove. And the reason for that is because it's congruent parts of congruent triangles are congruent. Okay. Have a look at that. Look at what you did. See where you went wrong. Let me know if you have any questions. Now would be a good time. Hope that was clear. Okay. Again, if you're stuck and you're like, I don't know where to go with this, also weird and parallelograms. No, it's just the triangles again. Just find two triangles and prove them congruent. Now, I did AEB and CED, but actually you didn't have to do those two. You could have done ADE and CBE. But I'll tell you one thing that a lot of people did that was not going to work was they took the big triangle. What I mean is, let me try to find a good color. What they did is they took this triangle and the other one. The problem with that, and that's fine, you can do, I mean, you could prove this one and this one congruent, but it's actually not going to help you because exactly, it's not, what you're looking for is some triangle that contains AE and CE. Because, but it does contain it. Look, it's right there. It's part of it. Yeah, no, I mean that it's explicitly one of the sides of the triangle. Okay, so it's not going to work if you take the big triangle. You really have to get a triangle that has AE as a side. Okay, so for example, you could have done this triangle, right, and the other one on the side, because that contains AE, and then the other one would contain CE, right? That would work. You could prove those triangles congruent, and then you would have it. But what a lot of you did is that you took the big one. You try to prove the big one congruent, but that doesn't actually help you because it doesn't prove that AE or CE is congruent. So that's what happened on that one. Now we're ready to move on. All right, the one everyone hated, the quadratics. Actually, I take that back. A lot of you guys, what I learned is that a lot of you know the quadratic formula, and you're able to set it up. But as I always say, the problem with the quadratic formula is the follow-through, is that so many of you mess up on your simplifications. And it's just a matter of being meticulous and remembering all of your PEMDAS rules and negatives and all that good stuff. But that's always tricky. It's always it's perilous. It's like walking a tightrope. The first one was better. The second one was not as good. So let's look at the first one. So I do recommend that you write out your A, B, and C. So we have that. And so that gives you 19 plus or minus the square root of 19 squared, negative 19 squared, but the negative goes away when you square it. I'm going to go ahead and cheat and just tell you it's 361. And minus 4AC, so that's 4 times 5 times 12. So that's minus 240. All over 2a, so that would be 10. Then that becomes 19 plus or minus the square root of 121 over 10. And that is 19 plus or minus 11 over 10. And then you could take this two different ways. You could say it's 19 plus 11 over 10, which is 30 over 10, which is 3. Or you could say this is 19 minus 11 over 10, which is 8 over 10, which is 4/5 or 0.8. Either way is acceptable. So that's the answer for that. It's 3 or 4/5. I tried to give some partial credit if you at least set up the quadratic formula correctly. I think there was one or two of you that left it in factored form, and you did it correctly in factored form, and but you just didn't give me the solution, so I think I gave you like pretty good credit on that. But there's that. That's what it is. So this next one here is a little bit tougher, and I'm going to have to erase this, so hopefully you got all that. Did you need that? Because I can put it back. Everyone good? Can I move on? All right. Dum-dum-dum-dum. Hope I all had a good weekend. Hope you're ready for more math. Alrighty. So this next one here, and actually a lot of you missed step 1. Step 1 is to subtract 2 on both sides, because you can't actually use the quadratic formula unless it's equal to 0. And many of you forgot that. So just a little reminder, if you're going to use the quadratic formula, you got to have it equal to 0. That's the only way that works. And also a little side note, if you're doing this online, you're watching, this one's going to be real funky and give you an imaginary answer. If you want the problem I think they meant to write, then make this 3 and try to solve for that. And that should make that a lot nicer and easier. And maybe next year we'll fix that and have it be good. So let's subtract 2 on both sides, and we get 3x squared minus 5x plus 3 equals 0. And so that means that a is 3, b is negative 5. That looks like a positive 5. Let's fix that. And c is 3. And let's set it up. So that means we have 5 plus or minus the square root of 5 squared. I know it's negative, but it goes away. Minus 4, I'm going to write this out, 4ac. And many of you will see where you went wrong on that one already. Because you didn't write in the correct value for A and C. And that was usually either because you didn't subtract 2 on the first one, or just a mental flub. It just, you just messed it up. It happens. And then let's go on to the next row. I think I can fit this in here. So that would be 5 plus or minus, maybe not. I'll do another row. 5 plus or minus the square root of 25 minus 36 all over 6. And that's going to be 5 plus or minus the square root of negative 11 over 6. And if you got that, I gave you credit. That was the answer. What's that? Restroom? Yeah, okay. Hopefully there's room there. I have another paper, actually. I think I made a new one. So this should be the answer, or if you have it in I format, you can say this is 5 plus or minus I root 11. And you can do the whole thing over 6. And if you really want to be extra and do it in an A plus BI format, you can put this over 6 and this over 6 and put that in front of the I, And then it's an A plus BI format, which will make everyone who's doing complex planes much happier. But that's not in the IM2, so don't worry about that. If you just had that red part here, let me circle that. This right here, that was full credit. Only a few of you got that. So I think it was only like 2 people. Question?
So when it's already negative, like for b on negative 5x, would it just make it positive when you put in the quadratic formula? Because like it's already...
Yeah, so if you notice that the question was about b switching to negativity. If you notice here, this one here, I made that positive.
Yeah.
And that's because it's negative b. So that's probably me like swallowing a step and trying to save space. Because if I was really thorough, I would write minus negative 5, right? And then on the next step, I would simplify that, and now it's positive. And I kind of, I kind of sped that up a little bit. Yes.
How did you get to 0? Like you said you divided by 2, but how did you?
How did I get to 0? So like this right here, I subtracted 2 and I subtracted 2.
Oh, I thought you meant that you like divided the whole
No,
thing by
no
2.
division. No, just adding and subtracting. Yeah, good question. Yes, that's how I got that to equal 0. Any other questions? I hope they don't do imaginary ones again, because that was cruel. But I will try to compensate you for your troubles. Okay, next one. A lot of you overthought this. You saw triangles and you thought it was trig. And that was to your detriment. So it says here, this is why you got to read, right? Using special right triangles, not trigonometry. Just the special right triangles. Find the values of the variables. Leave it in exact form. And that was another problem. A lot of you did decimalization. And I did not want decimalization. I wanted it to be with exact form means that you leave it with the radical. And frankly, I feel good. I don't feel petty about that because it is very important that you're able to break the triangles down and know the rules with the radicals and the ratios, and not use a calculator, not like find sines and cosines and whatnot. Like, it's important that you understand the radical breakdown, because as you go forward in math, just factoring lengths of sides and understanding the ratios is going to be important. It's going to be more important. So I don't feel petty if I took off points for you decimalizing, because it is important. So here's how you do this, though, because a lot of you did trip up. And you know what? I don't blame you. There's so much to go over, and okay, fine, you messed up, but it's not the end of the world. So what am I trying to say? Well, I know that these two sides here are the same, because this is an isosceles right triangle, because that's a 45, 45, 90 triangle. And if those are the same, again, we're in a 45, 45, 90 triangle, that means that whatever the hypotenuse is, it's one of the shorter sides times the square root of 2. So I'm going to take one of those shorter sides, we'll call it, or legs if you want, we'll call it x, times the square root of 2, that's equal to 10. So if you take 10, this 10 right here, okay? So if you have 10 equals x root 2, just divide both sides by root 2. And if you divide both sides by root 2, you get 10 over root 2 equals x. And that would already be like, I don't know if it's a full credit answer, but it's pretty darn good. And the reason why it's not full is because you're not allowed to have a radical in the denominator when you submit your answer. I will often do math with the radical in the denominator. I know, don't tell anyone. It's illegal, okay? But I will do that until I give my final answer and I'm ready to present my findings and say, Yes, here it is in standard form with the radical in proper location. So what does that mean? Again, just to be thorough here, if you multiply this, I'm running a little out of space. Maybe I can move this down. Yes, I can. If you take this and you multiply top and bottom by root 2, what do you get? Well, you get 10 root 2 over root 2 times root 2. What's root 2 times root 2? That is 2. And then you're like, hey, my gosh, top and bottom, they both have a 2 in common. We can factor that out. So we can divide top and bottom by 2. And then our answer is 5 root 2. And that is the answer I was looking for. And it's the same for both. So they're both 5 root 2. Questions on that one? Next one. This is a 30, 60, 90 triangle. You're supposed to realize that the interior angles of a triangle add up to 180 degrees, and therefore the missing side is 60 degrees. Once you have that, you're also supposed to know that the shortest side is half of the longest side, which thankfully many of you got. In fact, most of you got. And then the second longest side is whatever that shortest side is times the square root of 3. So 5 root 3. Again, get away from decimalizing and just learn the ratios. The ratios are super important, especially if you're going to work out the unit circle when you're going to get into IM3, and then you need the unit circle for calculus. So I don't know if you're going into calculus, but probably you're going into IM3 at least. And you're going to need that unit circle, and you're going to need to know how to break down special right triangles, and you're going to need to know the ratios because that's coming up. Not in this class, but it's important. Whew. All right, number 7. So for this one, you just need to use Pythagorean theorem. And again, a lot of you overthought it. You're thinking it's some kind of crazy trig thing. But it's just basic Pythagorean theorem. 5 squared plus a squared equals 8 squared. So 25 plus a squared equals 64. So therefore, subtract 25 from both sides. A squared is 39. And so the answer is the square root of 39. A lot of you decimalized it. I was going to take off points for that. And then I realized that the instructions basically said you're supposed to decimalize, like you can round it to the nearest tenth. So I was like, fine. But what I didn't like is that some of you rounded to the nearest integer. And that was not acceptable. It's supposed to be if you're going to use a decimalization, then do it right. Then do it the way they asked you to, which is to the nearest tenth. And so I did take off points, which was sad because a lot of you really needed those points. But that's what it was. So this is like what, 6.2-ish? So that was the other acceptable answer. Then we get to the next one. So for these next 3, you do need trig, and so you do need a calculator. And overall, you guys did pretty good. Most of you remember your trig, which is great because a lot of people find that stuff confusing. If that's one of you, then please pay attention because you can do it. So what do we have here? Well, we have the sine of 46 degrees. And how do I know it's sine? Well, from this angle, we have the opposite side, and we have the hypotenuse. So this equals the opposite. That's supposed to be a 9. I think that's better. Over the hypotenuse, which is b. And before I even find that, I could rearrange this and isolate b. So what I would do is I would multiply both sides by b. And then I would divide both sides by the sine of 46. And what that gives you, if we write it better, is what we get is b equals 9 divided by the sine of 46. Somehow that didn't get in there. All right. Sine of 46 degrees. And now make sure that your calculator is on deg and not rad. And if it was on red, you had a bad time. Always make sure that your calculator is set to deg. So, and then also these things are a little finicky with the multiple operations and stuff. So sine of 46 degrees is about 0.72-ish. And so we have 9 divided by that. Whoops. My calculator, I apologize. Let me write okay. 0.71933. 0.71933. 0.71933. Okay, so that was about 12.5. And that was the answer. Hooray. And that's rounded to the nearest tenth. And then the next one. This one here from this unknown, well, actually from this angle here, I should say, we have the unknown opposite side and the known adjacent side. So no hypotenuse tells me it's tangent. So we're going to use tangent of 58 degrees equals opposite over adjacent. And this one was a lot easier, and a lot more of you got it right because there wasn't weird dividing by the variable stuff. And so a lot of you guys did a lot better on that. So for that, you just take the tangent of 58 degrees, and then you multiply that by 22, and you get about 35.2. So C equals, if you can see, 35.2. Right, and just to be clear, these cancel, and so C is just this. And just in your calculator, just find tangent of 58 and then get the result and multiply by 22. And then you have your third side. And then this next one here, which we have adjacent and hypotenuse. So this is cosine. So cosine of D equals adjacent over hypotenuse. But this time we have an unknown angle. This is the only one where there's an unknown angle. An unknown angle means inverse. So we have to do the inverse cosine. So that means we do inverse cosine of, try to make that a little snappier. And let me use a different color actually, just to make sure we don't get confused. 11 over 13. Okay, and what's that going to give you? That's going to give you D. And I like to write that just to make sure I don't get confused, because I do easily get confused, and I'm sure that you do too. Otherwise, you'd have a perfect score. And so that's what we have. So let's put that in the calculator. So I'm going to do that little operation here, and then we're going to do the inverse cosine. And oh my gosh, it's about 32.2. So this one here is 32.2. And that's it. Questions about this one? Yes.
When I was doing it, I got it correct, but I switched D to theta because I thought because it was unknown that it was okay.
Okay.
I don't know if that's...
That shouldn't make a difference.
Okay. I mean...
I don't think I graded you down for that.
I put it like as D, I just wanted to know because it's just like unknown. Like,
I mean, I prefer you to leave the letters that they use, but I'm not that petty. I mean, I'm petty, but I'm not that petty.
I left it. I just wanted to make sure.
Yeah, it's fine. Theta is okay. All right, this one was actually tricky. Some of it was tricky. All right, let's just do this. So this one is the fifth root of m squared. So that should be m to the 2/5. This next one, though, is m cubed. And that was tricky. Oh, man. They got you. You fell for that trap, a lot of you. They got you because you're like, well, yeah, it's a fraction, right? Like 3/2. It's some kind of like they said fraction. I mean, if they said fraction, then probably there's a fraction. But 3/1's a fraction. So yeah, it's just m cubed. A lot of you fell right into that. Okay, and then for these here, I accepted either if you wrote fourth root of 81 or simply 3. Either answer was acceptable. And same thing for these here. So actually, let me write that in. Same thing for this one here. So you could write cube root of 64 squared. And it didn't even matter to me if you squared the inside or the outside because I told you it's arbitrary. And a lot of you actually squared the inside, which I would never ever do because I don't want to square 64 and then find the cube root of that. But, you do you. But just as a general advice, if you're going to do a fractional exponent on a number, take the root first. And then, then do the squaring. So cube root of 64 is 4. 4 squared is 16. So this is 16. And that is the answer. And that is all. Thank you very much. Please like, share, and subscribe. Buy my merch. I don't have any merch. Have a good day.